Well, hello everyone, and welcome back to Adrian's Digital Basement 2 Super Mini Mail Call. Let's get right to it. This package, which is rather heavy, comes from Elmer's. Elmer's is from Youngstown, Ohio, and we've definitely had packages from Elmer's before in the past. I'm trying to recollect, and I think Elmer's sent in like a whole bunch of really cool chips and stuff in the past, among other things, of course. I see packing peanuts in here, so I'm gonna have to start taking things out carefully. Ooh, what's that? I don't know. Let's take everything out and we'll look in a second. I don't want to throw anything out accidentally, so I'm carefully getting these out of here. I think there might be a piece of test equipment in here, something like that. Let's see. There's a note here. Let's keep digging in the box here. Oh, some nice looking sockets or connectors. All right, I think that is it. All right, let's go to the note. Elmer's. A few days ago, I was doing a bit of cleanup in my lab/junkyard, and I stumbled across a few items you might be interested in. Big piece of gear is a Huntron Tracker. It must be a very old model, as the Huntron website does not have any references at all to this machine. However, it does work and works just the same as the newer machine. I found a very detailed manual describing how to use the newer models, specifically how you use it for diagnosing systems. The cool part is that this tool can be used to test a known good machine against a broken machine. The tool can also be used to test various semiconductors in a power-off state and confirm they behave the same as known good samples. Since you repair a number of common machines and have reference machines you can test against, you might find this handy. In the box, there's a small bag of test leads, here it is, that came with the unit. In the bag are also some Apple II Plus ROMs. Ooh, that's cool, right here. These are all I've been able to find from our old Apple II, and that machine had a low 4-digit serial number. Wow. Handwritten on the motherboard. It received all the hardware tricks to bring up to a 2 Plus and beyond. Printers at the time in 1978 were so hard to come by. My dad found an old teletype machine and hacked the interface to the Apple printer card. So freaking cool. Anyways, have fun with your new toy, Elmer's. And there's a handwritten section here. I also added a bunch of round hole sockets, various sizes, also a DB15 male, female, DB25, flat cable adapters. Ooh, those are very handy. Card edge slot, probably from an Apple II, flat cable to pin adapters, Apple II keyboard connection. Oh, you know, Elmer's, these are very useful things, and more. Forgive the peanuts, any I receive get sent to someone else, never trashed. Elmer's. All right, that's awesome. All right, let's take a look at what we got going on here. There's some extremely useful sounding things in here. Okay, so this is like a nice hood with has a socket inside of it. So there's a card edge connector. Yeah, this might be for an Apple II. Very interesting. So, oh, right. So this, hopefully the other part of it is in here. What this is, oh, darn it, it doesn't look like it is. Oh, there it is. It is here. Okay, so what this is you could take a 40-pin ribbon cable and you lie it across this thing, and this is the top part, and you clamp it together, and then it basically would allow you to connect a ribbon cable directly into a 40-pin socket, like a CPU, for instance. In the old days, this stuff was really common. Nowadays, it's really hard to find this, and I think a common solution people do is they make a little PCB that has the pins on it, and that would go into the socket, and then it would have a normal connector on it, like with the pins you would plug a standard cable into. But I just happen to have an IDE cable here, so yeah, what you would do is you'd put this across there, like that, lining up the pin 1, put that on there, and then I'd use my vise to clamp it together. Really, really hard to find this stuff now, so that is awesome. And there are some other sized ones here. Here's one that would go into a ROM socket. This would be pretty typical and common in the old days to hook up like a ROM expansion board to something like a TRS-80 Model 1 or an Apple II Plus or whatever. In fact, the nice thing about these is super low profile. You see the cable would go in there, and once this is all clamped together, it's barely taller than the IC itself. The Model 1 uses this for an expansion for the ROMs, plus a couple extra wires that go onto the motherboard. And the one on my Model 1 is all like rotted out and corroded, so I kind of had to make it work, but I might end up replacing it with this. And then what he mentioned is there are these, which are like DB25s, and you can stick ribbon cable in there and you clamp this together in the vise. There was a special tool originally for that. And that was a common way to connect ribbon cables to things like DB25 versus having to solder every single wire individually. I think these are still obtainable. Like you can still buy new versions of these from Asia, because I have bought some of these, not 25 pin ones, but smaller ones. But almost certainly these are extremely good quality ones with like gold on the inside, or really, really high quality connectors because they're old. So there's 2 of those. Here's a couple more. So there's 2 more there. And then there are these little clips. And what these do is once you have the cable clamped on, this would clip over and the ribbon cable would come out and loop around. And this is like a strain relief. It would just keep it from getting yanked. So there are matching 4 of those for those 4. Let's see what else we have here. Okay, we have a couple more ribbon cable attachments. So this right here is just for a small dip IC, and there's the top for it. It looks like there are several of these. Well, maybe not several, but there's 2. We got 3 of those. It looks like there is the female version of that right here, and that would go onto a ribbon cable. And I think that might be it. There's one more top for another one, but I don't see that connector in here. But then there's a whole bunch of these round machined hole sockets. These are really slick looking, like really, really high quality gold contacts. Most certainly probably from the 70s, where these probably cost $5 each or some really high end of cost, but really, really reliable, really good quality. Much better than that stuff that I typically use these days, which are super dirt cheap and not that great. Looks like we got some DB15s. There's another 25 pin one, and that also is ribbon cable. And we got a bunch more sockets, little tiny round hole ones. Those are nice. A couple conventional dual wipe ones. This is for a ribbon cable that would plug into a pin hanger. It's pretty standard stuff there. But yeah, really neat stuff. This 40 pin one is pretty awesome. I really like that. And let's take a look to see if this edge connector is actually for the Apple II. So I have a little prototype card here, which actually comes from the Commander X16. Whoa, I just dropped that chip. But this actually uses the same exact size connector as the Apple II. I'm pretty sure this is the same size, and yes, it is. So that is cool. I intend to make a project. I have that Apple II clone that was sent in by a viewer, and it uses a larger connector, but I'm pretty sure it's Apple II compatible. That's this. What I want to do is make something that goes from the larger connector underneath on the motherboard to a standard Apple II connector, and then I can take a Disk 2 controller card, stick that in, and actually run disk drives on that thing. I definitely plan to get back to that, and this edge connector for the Apple II is super helpful for that. I'm gonna have to hand wire all the connections, but that makes the difference. So thank you very much for that. Let's take a look at these ROM chips here. So F8 lowercase and Apple II Plus keyboard. So I'm gonna take these out of this foam, because this foam starts to corrode the legs on ICs after a while. So we're just gonna take those out. Luckily this hasn't really turned that sticky yet, but it starts to become corrosive. So if you have old chips, I wouldn't leave them inside that foam anymore. So yeah, F8 lowercase. It's probably a modified AppleSoft ROM. The keyboard actually has some rudimentary support for lowercase, and I plan to do a video on that actually. So I will eventually. So these might become useful to modify the keyboard to make it work a little bit better with lowercase. I don't know, I'll have to investigate what this is all about. All right, what is this Hunter thing? So this has a, what, a 1/4 inch jack, I think that is, or 1/8 inch. When it has some pointy probes on here. Wow, this thing, the wire feels very old. So here is the Hunter device. There it is. Let's see, it's got a piece of peanut there on this, what looks like an LCD screen. How do I move this? Oh, there we go. This is funny here. I thought this was broken, but no, it's not. This one has like this thing here going on. Huh. Isn't that strange? Well, I guess you know what it is? It's to help this thing stand up. Like that. So a Huntron Tracker. I think that says signal maybe? Or something. Vertical, horizontal. Got some push buttons here. The whole thing just looks a little, how we say, handmade. Like the way these buttons are cut out here, and this, we have a fuse and we have a knob here. Judging by the age of this, is this a tiny little CRT, like a little oscilloscope type thing? It has a standard US style plug, so I'm gonna plug this in and we're gonna see if this works. Make sure the power's off. Hopefully no magic smoke comes out when I put it on medium, I guess, I don't know. Okay, we got a power light. All right, when I turn this knob up, there is a green line there, so clearly, aha. Right, what is this thing? I wanna know. What's this knob on the back do? Is it focus control? It is. Razor sharp focus there. All right, a little quick search. Huntron Tracker circuit board tester and troubleshooting. Tracker signatures. Analysis works by comparing green versus bad. The Huntron Tracker power off circuit board test uses analog signature analysis to detect and isolate component faults on boards beyond power on function testing. By comparing the tracker signatures for a working circuit board to the signature of a non-working board, you can troubleshoot down to the component level. To learn more, download the Fundamentals of Analog Signature Analysis 19-page extract or go to Huntron contact page. And they still sell stuff that looks very, very similar. I mean, it's in more modern looking cases. The number of voltages, 24 voltages, 6 voltages, number of resistances, number of frequencies. What does this do? And here's that PDF that I mentioned to download, and yeah, there's some good fundamentals in here. So I'm gonna have to read up how to use this. It seems like newer versions have like a digital, instead of this analog scope here, you can look at it on a computer, stuff like that. Signatures on the left show a damaged transistor leakage. Yeah, that's what I thought this looks like. Is this like what are these things called? You know, Curious Mark would definitely know exactly how this stuff works. When you have a diode or you have a transistor, you know, there's like breakdown voltage and things, and you can have something like this that can show you a curve. Curve tracer, is that what these are called? Let me grab something and just try it out. So here's an IRF 630 here, pretty standard stuff. Let's see what happens if I touch these probes to it. I see it changing slightly. When I push the low button, we get this diagonal. Medium is like that, and high stays like that. So why don't we try low? So if I touch the probes together, you get a vertical line, and then the other lines don't do anything. Let me swap the probe around. Well, I don't know. Let's try this setting here. Okay, there we're getting a stair-step looking thing. Okay, there we go. On this one, on these two legs, we're getting an L shape. I think this has something to do with like the breakdown or whatever of the diode that's in here or something. I'm gonna have to do a little bit more reading. I'll be back. All right, so I've done a little investigation on what the three settings are here. As Elmer's mentioned, there's no documentation for this particular unit, but I did hook these probes up to an oscilloscope, and I found that the low setting, where's my little notes here? Oops. Low setting outputs 10 volt sine wave, so it goes above and below ground at 10 volts. Medium is 30 volts, and high is 60 volts. Now, I think there might be a fault with this unit though, because I think all three settings should have a flat line like that. And I'm not exactly sure why this one doesn't have it. But if we take this 16 volt capacitor here, and I have it on the low setting, and we touch the probes to the legs, whoops, it's definitely a little fiddly. I wish these had like clips or something on them. And then there we get sort of a flattened circle. Now that's on the low setting. This is only a 16 volt cap, but you know what, I'm just gonna go for the medium, which is 30 volts, a bit too high. But okay, when we try that, we just get a solid line. I clearly got to do some reading on this thing. Let's grab the iPad. All right, here's the Huntron page, and take a look at this analog signature analysis, and troubleshooting with signature analysis by comparing a good green versus bad circle. And remember, well, look at that. that circle, the green one, looks just like the one on the capacitor we were just looking at. So these are the more modern ones that they have. They seem to have LCD screens on them, and they look pretty modern, actually, in normal looking probes as well, versus these funny little tiny ones here that end up hooking up to that what looks like a headphone jack on there. So they have different versions here. Tracker 3200 has 24 voltages, 16 resistance, 40 frequencies, all the way down to the lowest model, which has 6 voltages, 9 resistance, and 6 frequencies. Well, this thing, like I said, only has 3 voltages, and I didn't take a look at what the frequency was, but I wouldn't be surprised if it's 60 hertz or something like that. So there's an article here, Fundamentals of Signature Analysis. The Huntron Tracker outputs a precision current limited AC sine wave signal to a component and displays the resulting current flow. The current flow causes a vertical trace deflection on display, while the voltage across the component causes a horizontal deflection. The resulting trace on the display is called an analog signature. All right, and here it is. It says here, display with open test terminal. So it should be this horizontal line that we're seeing on here now, but unfortunately, like I said, the low setting, which of course is the one that I need to use, doesn't appear to be working properly. So it talks about different voltage ranges on the versions of these that actually are a little more modern, including a 200 millivolt range. All right, so here we go, a section on the 4 basic component analog signatures. First one, resistance. Diagonal line. Certainly looks quite a bit like this one, doesn't it? Inductance, you get kind of an oblong shape. That's the phase change happening. There's capacitance, you get that circle, kind of an oval. And then a semiconductor gives you this L shape. I have this IFR 620, I think it is, or something. Let's take a look at this. Let's see what we see. All right, so if I short the leads, we get a vertical line. And I'm assuming this should be what a resistor looks like. So again, I think something's broken there. Okay, so that's the semiconductor signal and not looking right. Yeah, between 2 pins here. There we go. I'm assuming it should look like this, but it's not. Oops. Let's try it on the medium, or at least it's looking flat. And let me test those 2 pins that were giving us that little... All right, there we go. Between these 2 pins, we're getting an L shape, like a turned L shape. And but if I reverse the polarity on those, okay, that gives us that shape. So I don't know, it's all kind of mysterious to me. What's going on with this thing exactly? So I would love to hear from any viewers in the comment section. If you're familiar with how this thing is supposed to work, especially this one, like why the low has this diagonal thing going on, if that is right or wrong, or perhaps someone could find a manual for this. There is no model number information anywhere on this, by the way. I've looked on all the sides, no serial number, nothing. Like if there were labels, they're gone now. So yeah, interesting piece of kit. I am concerned about these voltages though, like 10 volts peak to, well, it's not even 10 volts peak to peak. It is actually 20 volts peak to peak because it goes plus 10 and down to minus 10. So I'd be afraid to put that into a piece of equipment that had DSLogic chips, for instance. I mean, I don't even know if I've damaged this transistor or whatever this is. But in that document on the iPad I was reading, it talked about doing this against DSLogic chips, and you could check to make sure that there wasn't leakage on those output pins and stuff, but putting 30 volts or 60 volts, and that's like 120 volts total, into a delicate piece of test equipment, I'm not quite so sure about that. So yeah, I'd love to hear people's thoughts on this thing. Definitely let me know what you think, because I'm kind of scared to use it. It's a neat piece of equipment though. I love the little tiny oscilloscope CRT tube in there. It's all very cool. So thank you, Elmer, for sending this in. Thanks for all these really awesome, very high quality components as well, along with these Apple II Plus ROM chips here that look like they're for the keyboard or something. Or maybe the character generator. Yeah, lowercase ROM. I'll have to investigate that at a future time. So that's going to be it. So thanks very much to everyone who sent stuff in. I'm going to be trying to get through packages. I still have a bunch of stuff that I haven't gotten through. in 2021, a lot of it. So it's coming, don't worry about that. Thanks to my patrons who have been supporting me. I really appreciate their support. If you want to become a patron, you can do so as well. There's a link in the description below. And I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye.